Digestion starts with the horse's mouth. Mastification, which is also known as chewing, is a grinding motion from side to side. This produces saliva, which makes it easier for the food your horse has eaten to digest, preventing your horse from getting choked. Once chewed, it travels to the pharynx. This is where the respiratory and the digestive systems meet. There is a small flap of tissue that prevents food from entering the respiratory system when swallowing. The food then goes down the esophagus. To help the horse swallow his food without getting any cuts or abrasions from the rough forage, it has a barrier called the squamous epithelium. The esophagus moves the food through in a wave-like motions. This is called peristalsis. The esophagus empties into the stomach, and this is where the real action starts. Your horse's food passes through the stomach within 30 minutes. There are two main parts, the glandular and the non-glandular region. The non-glandular region has no mucous membrane to protect itself from the gastric juices, so this is the most common site for stomach ulcers. The food will first hit the glandular region. This is the bottom part of the stomach, and it is lined with a mucous membrane. This protects it from the gastric juices. When it reaches about 2/3 capacity, it will start emptying into the small intestine, which is also known as the SI. The gastric juices contain hydrochloric acid and two enzymes, which are pepsin and gastric lipase. Proteins are digested in the stomach by pepsin and gastric lipase. This helps to start digestion from fats into fatty acids and glycerol. Some of the juices needed come from the pancreas. A constant secretion of pancreatic juices help break down the cellulose material your horse eats. It also helps the hindgut maintain a stable environment for microbe survival. There are three sections to the SI: the duodenum, jejunum and ileum. The duodenum is situated right after the stomach, and this is where the food is mixed with enzymes from the pancreas and the intestinal glands, as well as bile from the liver. The food is then passed to the jejunum. This is where the nutrients are absorbed. Finally, the food is passed to the ileum, and this just connects the small intestine to the large intestine and the hindgut. The inner lining of the small intestine has finger-like projections called villi. These help nutrients to be absorbed. Amylase is responsible for breaking down the starches in the diet into simple sugars. It manages it really well just until there is too much starch in the diet. Then it starts to store the starch, which will eventually cause some metabolic issues. The last section of the small intestine is the ileum. This just joins the SI to the hindgut. There are three main parts to the hindgut: the cecum, the large colon and the small colon. Food that reaches the hindgut that is not yet being digested will be done so by fermentation rather than enzymes. In fermentation, naturally occurring bacteria and protozoa, known as microbes, digest the fibre in a horse's diet. Microbes have three functions. These are to produce energy through volatile fatty acids, to synthesize B vitamins, and to synthesize amino acids. In the hindgut, the first part the food reaches is the cecum. The food is here for around 7 hours, so it has plenty of time to make sure that any undigested food does so here. There are lots of fold in the cecum, and if there is not enough water, food can get stuck. This causes impaction colic. Changing a horse's diet needs to be done really slowly, as the microbes in the hindgut adapt to the specific fibre your horse eats, and eventually your horse has a specific population of microbes for the type of food it eats. If it is switched too fast, it can lead to gas being produced. This results in your horse getting gas colic. The large colon is about 12 feet long. This is where absorption of water, electrolytes and short-chain fatty acids occur. When the hindgut does not have enough fibre in the diet or too much starch and sugar, the microbial balance is uneven, meaning the good fibre digesting microbes start to die off, while the starch digesting microbes increase. The dead microbes get released into a bloodstream, which causes a poison. This causes laminitis. After the large colon, the food passed into the small colon, which is about 9 feet long. Most of the nutrients should be digested by now, and the small colon prepares the waste material into small balls of feces. The final two parts of the equine digestive tract are the rectum and the anus. The rectum is 1 foot long and connects the small intestine to the anus. The fecal balls pass through the rectum and out the anus. That's the complete works of the equine digestive tract. Thank you for listening. I will now pass over to my friend Cathy, who will explain more on nutrients needed for a healthy horse.
Water is the most important nutrient and is used in virtually every life process, including digestion, which occurs in a water solution. If a horse does not have enough water, this can cause colic, collapse of the kidneys and death. Calcium helps maintain healthy bones and is needed in the transmission of nervous signals, among other things. Oats are high in phosphorus, which is also needed in bone, but too much reduces the availability of zinc and calcium in the GIT. Calcium and phosphorus should be fed in the ratio of 2:1. Magnesium is an important component of blood, and it is a cofactor in many enzyme-catalyzed reactions. Sugar beet is high in calcium, low in phosphorus, and a good source of magnesium, but contains few water-soluble vitamins. There are many minerals, but these are the main ones. Sugars, such as glucose, are the building blocks of carbohydrates. Glucose fuels most cells. Starches are chains of sugars joined together with loose bonds, and are broken down to simple sugars such as glucose or sucrose. Fibre consists of chains of sugars joined by stronger bonds, making it very tough. The main uses of carbohydrates in the horse is as an energy supply for muscles and red blood cells, and as the main energy storage in muscles. Fibre is needed to aid digestion. Oats contain lots of starch and more fibre than other cereals. Sugar beet is a good source of fibre, and often has molasses added to increase palatability, though unfortunately this also reduces the digestibility of its fibre content, as Frape 2010 found. Fats and oils consist of chains of 2 or more carbon atoms with oxygen and hydrogen branching off, and they contain the highest energy yield of the 6 main nutrient classes. Horses can synthesize saturated fat themselves, but not unsaturated fats, including essential fatty acids such as omegas 3, 6 and 9, which are needed to produce certain hormones. Fats are a component in cell membranes and are needed to produce certain hormones and enzymes. They are also used as energy storage. Linseed is a great source of essential fatty acids. Proteins are made up of amino acids, of which there are approximately 22. Some of these the horse can make themselves, but there are 10 called essential amino acids which must be supplied in the diet. One of the most important of these is called lysine. Protein is the main structural component of the body, and is what enzymes, including those used in digestion, are made from. It is also used for the growth and repair of cells and in the bone matrix. Horses must be fed high-quality protein, i.e. that which contains high levels of essential amino acids. Feeding too much protein puts strain on the liver and kidneys, so it is best to feed small amounts of high-quality protein, such as that found in soybean meal, which has a good amino acid balance, including lots of lysine. Oats contain more protein and have a more balanced amino acid content than other cereals, but are not as good as soybean meal. Vitamins are carbon-containing compounds that are either fat or water-soluble. Horses need them in very small amounts to efficiently carry out many body functions. For example, vitamin D helps maintain the plasma calcium concentration. A and E are the only vitamins not made inside the body, but they are found in leafy green forages, so not hard to come by. Vitamin supplementation in horses is rarely necessary. So now that you know how important it is to feed the right stuff, let's put this into context and explain how Alan and Paige can help you and your horse. Let's say you have a 9-year-old, 15-1 riding school horse in medium work who weighs about 500 kilos. He would be great on our cool and collected mix. This will give him the energy he needs, but is low in starch, so won't make him fizzy and difficult for novices to handle. Here's another example. You have a 10-year-old, 17 hands, warm-blood broodmare with a 1-month foal at foot. As you can see, her nutrient requirements are more than twice that of our riding school horse. Luckily, at Alan and Paige we have the answer with our stud and young stock mix, which has extra micronutrients to help with milk production. Feed small feeds of no more than 2 kilos each, and feed as many feeds throughout the day as you can, as horses are trickle feeders by nature. 3 or more is ideal. Horses are designed to spend 16 hours a day eating mostly fibre, so feeding lots of forage such as hay is important, as it leads to better digestion, more natural behaviour and better welfare. If you need to slow your horse down when eating grass or hay to make it last longer, use a grazing muzzle or hay net designed to reduce eating speed.